So at first glance here, we might say, hey, this is a rational function, polynomial on the top, polynomial on the bottom. I can just cheat and plug in. But if you do cheat and plug in, then what you'll see here is that 4 cubed is 64 and 4 minus 4 is 0. So you get 0 over 0, which is what we call indeterminate. Indeterminate. And indeterminate 0 over 0 could be 0, but it could be 1. It also could be infinity, and it could be 3 or pi or 7 or 1/2. Who knows? Okay, so it may exist, it may not exist. So we have to do some work on this. 2 ways to do, 3 ways to do work. Take some numbers approaching 4, plug them in and see what happens with the fraction. Look at the graph, or whip out a little algebra, and I'm going to focus on the algebra part because you guys are really good at looking at graphs. So algebra, I hope to carry out this division. I want to take x minus 4 into x cubed minus 64, or I want to try and factor x cubed minus 64. And you may recognize that that is the difference of 2 cubes, and you may remember that formula from your past life in algebra. I'm going to assume you don't, and I'm going to do some division. In a past video, I did long division on this. I'm going to do synthetic division today. Synthetic division works when you have 1x plus or minus something. If that was a 3x there, I cannot use synthetic division. I would have to use long division. It has to be a 1x. All right, so with synthetic division, once I recognize that I can use it, that's a 1x plus or minus something, I look at the number that makes this denominator 0, and the value is 4. And so then I isolate my 4. Then I consider the numerator, and I have to make believe that this numerator not only has a cube, but has a square and a first power all the way down. So this right, and I only write the coefficients. So that right there is 1x cubed. There are no x squareds, there are no x's, and then there's the minus 64. So you have to keep track of each power in synthetic division. Then I make a little bar down here. And in synthetic division, you bring down the first number, and then you multiply by that number based on the denominator. So 4 times 1 is 4. And then you add coming down, 0 plus 4 is 4. And then you multiply, 4 times 4 is 16. And you add coming down, 0 plus 16 is 16. Then you multiply by 4. And then you add coming down. And this number over here is always your remainder. So I get a remainder of 0 here. So what that means is x minus 4 goes into x cubed minus 64, 1x squared plus 4x plus 16 times. So that means this right here is equal to that right there, because I got a 0 remainder. So now I can say, all right, what's the limit as x approaches 4 of x squared plus 4x plus 16. And since that is just a polynomial, I can just plug in. It's going to be 4 squared plus 4 times 4 plus 16, which is what? 16 plus 16 plus 16, or 48. So if I look at the graph of this rational function right here, what I'm going to find is that there's a hole when x equals 4, but the y value appears to be about 48. So let's take a peek at the graph. And let's reset. Function f of x equals fraction x raised to the third minus 64 divided by x minus 4. And if I ask, hey, what is f of 4? I should get back an undefined. And then I just need to find that point. So I'm just going to zoom out. And then let's adjust the vertical scale with the monkey wrench over here. Let's go up to 100 maybe. And 48 will be kind of in the middle. All right. And then if I graph the line, x equals 4, right? I'm interested in that point right there, which on my function, the red graph doesn't exist. Now, notice this rational function looks like a parabola, and essentially it is a parabola, but with a hole in it. It has a hole at the point 448. But the original function doesn't exist there, it's undefined. So, did I prove my point with the graph? I think so. All right, let's try another.